guys, welcome back to my channel. So here in this video we're solving some higher order partial derivatives, also known as second order partial derivatives. Okay, so here we have our first example here, and we're asked to find f of xx. So if you're seeing this notation for the first time, it might sound confusing. What is this f of xx? So let me explain. So if you're familiar with the first order partial derivatives, you know f of x. So this means the derivative of this function with respect to x, which means we're keeping y as a constant, right? So here this notation means f of xx, which means first we are taking the derivative with respect to x one time, and then we are taking the derivative of the function of this function again with respect to x. So this simply means we're taking the derivative again with respect to x. Okay, so similarly, if you have f of y, so first you're taking the derivative with respect to y, and then you're taking the derivative with respect to y again. And in these cases, so first you're taking the derivative with respect to x, and then y, and first you're taking with respect to y, and then x. So I hope you understood. You have a general idea of what are these. If not, I'm gonna do some problems, so I'm pretty sure it will be clear after doing some problems. Okay, so let's start with the problems. Okay, so first of all, let's find f of xx. So like I said before, to find f of xx, first you will need f of x. So let's find first f of x. Okay, so here we have this function, so we're keeping y as a constant, so we're differentiating x only. So now let's do this. So bring the 3 down, x squared, plus bring the 5 down, and then subtract 1 from it, and keeping y as it is since it's a constant, and here it's a constant, it's only a constant here, and the derivative of constant is 0. Okay, now once we have f of x, now we have to find f of xx. So we are differentiating with respect to x, but now we're not differentiating this function. We're differentiating this function now because we already have f of x, and we are going to differentiate it with respect to x. Okay, so now we're taking this function and differentiating with respect to x. So you have to remember that y is a constant again. Okay, so now differentiate it. So bring the 2 down. So this becomes 6x, and then subtract 1 from it. Okay, plus bring the 4 down. So this becomes 80x, subtract 1. This is a constant, remains same. So this is our answer for f of xx. Okay, so I hope it was clear. If it's not, so let's do another problem so it gets even clearer. So now f of y. So for that, what do we need first? We need f of y first. Okay, so we are going to calculate f of y first. Okay, so calculating f of y first. So remember, the variables that we do not have in here are constant, so x is constant in here, so we're differentiating y only. So here in this function, the original function. Okay, now x is a constant, it's 0, and here we're differentiating y, so 3 times 4, which is 12. Oops, maybe just remove this. Okay, so bring the 3 down. So 4 times 3, that's 12. X is a constant, just gonna stay in there, and then subtract 1 from the y. Now bring the 4 down. So this is 20 y, subtract 1 from it. So this is it for f of y. Now let's move on to f of y. So now we already have our f of y, right? This function is f of y. So now we are differentiating this function with respect to y, which means what? We are keeping x as a constant. Okay, so now differentiate this function with respect to y. So bring the 2 down, so that's 12 times 2, which is 24, and then subtract 1 from y, so y, and this is a constant, so it's just going to stay in there. Now bring the 3 down, so this becomes 60. Subtract 1 from the 3, so it's 2. So this is the answer to f of y. Okay, so now let's go ahead and solve for f of xy and f of yx. So now if we want to find f of xy, what do we need first? I think you know by now that we need f of x first, but we already have f of x here, you see. So you are just going to differentiate this function, the f of x function, with respect to y, which means x is a constant, right? Okay, so with respect to y, so x is a constant, so the first one goes to 0, and then, okay, differentiating y, so bringing the 3 down, so 20 times 3, that's going to be 60. Okay, so we write in here 60, and this is a constant, so it's going to stay in there, and subtract 1 from the 3, so 2, and that's it. Now we have to find f of yx, and this is simply the answer to f of xy. Okay, f of yx, we need f of y first, right? We already have f of y, so we are going to differentiate this function then with respect to what, right? We're differentiating this function, and in there we were differentiating this function because it had f of x. Here we have f of y, that's why we're differentiating this function. If you didn't have this, then you would go ahead and calculate this first, f of y, and then you'll have to take the derivative with respect to x then. Okay, so now we already have this function. Differentiating with respect to x means we're keeping y as a constant, so now we're differentiating x only. So 12 times 5, this is going to be we're differentiating with respect to x, right? F of y of x. Okay, so now we're going to do 12 times 5, which is 60 x, and subtract 1 from the 5, so 4, and then y is a constant, so we're going to stay in there, and then here y is a constant, so this whole thing is going to go to 0 because a derivative of a constant is 0. Okay, so this is our answer to f of y of x. Okay, so that's it for the first problem. Let's move on to the second problem now. Alright, this is our second example, and here we are asked to find f of x of y and f of y of x of this function. So first let's find f of x of y, and for that you know that you will need f of x first. So let's find f of x first then. Okay, so we are finding f of x and we're keeping y as a constant, so differentiating x only, so bring the 2 down, so 2x y cubed because it's a constant. And what's the derivative of 4x? It's simply 4, and keeping the y squared as it is because it's a constant. Now we can take f of x of y because we already have f of x, and f of x is this function, okay? So now taking the derivative of this with respect to y, that means we're keeping x as a constant in here and differentiating y only. Okay, so differentiating y only, so bring the 3 down, so 3 times 2, that's 6. X is a constant, subtract 1 from the 3, so 2, plus bring the 2 down, so 8, y subtracting 1. So now this is the answer to f of x of y. Alright, so now let's move on and find f of y of x, and for that you know that you need f of y first, so you will calculate f of y first. So now you know x is a constant, so here we can differentiate it, so x squared, so 3y squared plus, okay, now 4 4 times 2, that's going to be 8. So 8 x and y. So this is our f of y. Now we can go ahead and calculate f of x of y because we already have f of y, but we are going to take f of y of x with respect to this function, right? So this function with respect to x. Okay, so y is a constant, differentiating only with respect to x. Bring the 2 down, so 3 times 2, that's 6. It's a constant, plus, okay, so we know that y is a constant, it's going to stay, and then the derivative of 8x, it's simply 8. So here we have the answer for the f of y of x as well. So now, did you notice anything? If you didn't, so let me point it out. So if you notice that these two answers are identical. So 8xy squared plus 8y equals 6xy squared plus 8y. They're exactly the same. How come? These are different questions. But, so that's the thing. So here, doing this example proves that f of x of y is equivalent to f of y of x. That means no matter how you take the derivative, so the order doesn't matter, because here we are taking the derivative of x first and y after, but here we're taking the derivative of y first and then x after, but it doesn't matter the order, so it's going to be same. Okay, so and similarly if you have, oh, it's too thick. So now, similarly, if you have f of x of y z, it's going to be equal to f of y x z or f of z x y, because you're taking the derivative with each component once. So the order doesn't matter. In each problem, you're doing the same thing, but it's just the order is swapped. So it's all going to give you the same answer. Okay, and similarly if you do f of y, y, x, that's going to be same thing as f of x, y, y, because you're taking the derivative of y twice and then x. So yeah, so I hope you got this, and let's do a problem on this so that it's clear that it's going to give the exact same thing. Okay, so let's do this problem then. F of x, y, if you're given a function like x sine squared of y plus y squared of cosine of x. So if you're given this function and if you're asked to find f of x, y and f of y of x, so what are you going to do? Okay, so your question is to find f of x, y and f of y, x. So just like that, you're going to find f of x of y first, but for that you need f of x first. So let's find f of x first. So here you know that y is a constant, okay? Differentiating x only, and the derivative of x is 1, and this whole thing, it's not a product rule, okay? Because this whole thing becomes a constant. So it's simply like 2x, right? Because this whole thing is a constant, just like 2. Okay, so the derivative of a constant, so here the constant remains same and the derivative of x is simply 1. So I'm going to write this, and then here the derivative of cosine of x, it's negative sine of x, and this is a constant, so it's just going to stay in there. So let me write it neatly. So y squared, and there was a negative here, so you remove the positive. Okay, so, and that's it for f of x. Okay, let's move on to f of x of y. Okay, so f of x of y, we know x is a constant and we're differentiating this function now, right? F of x with respect to y. So with respect to y, so here, if you don't know that it's a chain rule, so you can write it like this: sine y squared, because this will help you identify that it's a chain rule, because a function to the power of squared, that's a chain rule. Okay, so now you have to differentiate this with respect to y. So now So just a recap to differentiate the chain rule. So you bring the 2 down. So you bring the 2 down and you subtract 1 from it, and the inner function you just keep it the same and you subtract 1 from it, so that's 1. You write it or not, doesn't matter. And then afterwards you have to multiply by the inside function, okay, but the partial derivative of the inside function. So here we're differentiating with respect to y, so we don't have a problem with x being here, so there's no x here, so you're simply going to take the derivative of sine x, and the derivative of sine x is cosine y. The derivative of sine y is cosine y. Okay, so this is the answer to here. So 2 sine y cosine y. So if you're confused, let me recall. So let me repeat what I just said. So sine squared of y, you're taking the derivative of this with respect to y. It's a chain rule, so you can write it like this. And then for the chain rule, you bring the 2 down. The derivative of the inside function stays the same, and then you have to multiply by the inside function, the derivative of the inside function, and the derivative of sine x is cosine. Oh, I keep saying x. The derivative of sine y is cosine y. Okay, so I hope it's clear. If it's not, let me know in the comments, and I will make sure to provide you with enough explanation so that it's clear for you. Okay, so now we are on this one. So we're differentiating with respect to y. So bring the 2y, and this is a constant, so remain there. Now we are going to find f of y of x. So let's just separate it a little, okay? F of y of x, but first we need f of y. So let's find f of y first. We know we're going to keep x as a constant, so differentiating y only in this function, the original function, okay? So here x is a constant, going to stay in there, and this is again the chain rule, so bring the 2 down, and the inside function is going to remain the same, and then times by the derivative of the inside function. And what is the inside function? It's sine of y, so it's going to be cosine y, plus, so 2y, and then x is constant, is going to stay in there. So now we can go ahead and calculate f of y of x, and f of y, we already have f of y, so differentiate this function with respect to x now. Okay, so with respect to x, that means we're keeping y as a constant, right? So here we're differentiating with respect to x, this function. So here the x is only here, so what's the derivative of 2x? It's simply 2, and y is a constant, so this whole thing remains the same as it is. And now differentiating this one, so y is a constant, so it's going to just stay in there. And differentiating x, what's the derivative of cosine x? That's negative sine x, so we'll remove this sign of positive and make it negative sine of x. Okay, so so did you notice that we got again same answer, f of x of y and f of y of x? We got exactly the same thing. 2 sine of, oh, y it removed. So 2 sine of y, I don't know what's wrong with it. Okay, 2 sine y cosine of y negative 2y sine of x. So it's exactly the same thing that we got, okay? So that means that what I explained to you before, that's correct, right? F of x of y is equals to f of y of x, and we just proved it over here with another example. First we proved it over here, and now we just did it the same thing with another example, right? Okay, so let's solve another problem, but it's with 3 variables. Okay, so this is our last problem, and as you guys can see, this is a 3-variable function. And if you don't know how to find the first derivative of a 3-variable function, I have made a video on that, and I will post the link in the description below, so do check that out. And here we are finding the second order partial derivative of a 3-variable function. So here you have to find f of x, y, z, y, zx, and so on. So first let's calculate f of x, y, z. Okay, so to calculate f of x, y, z, we do the same thing. So first we see here there is f of x first, right? So we are going to calculate f of x first. Okay, so let's find f of x first. Okay, so now we are differentiating this with respect to x, and of course y is constant, but here not only y is constant, y and z, both of them are constant, because if we are differentiating with respect to one variable, we keep all the other variables as constants. So here when we're differentiating with respect to x, so what other variables are left? Y and z, right? So we're keeping them as constant. Okay, so let's continue with the problem. We are differentiating with respect to x and keeping y and z constant. Okay, so differentiating only x. So the 2 comes down, 2x, this is a constant, stays in here. Now this is a constant, this is a constant as well. So this whole thing is a constant, derivative of constant is simply 0. Okay, so this is the answer for f of x. Now we have to find the derivative f of x, y. So now we already have f of x here. Now we are going to differentiate this function with respect to y now, because you see here this is f of x of y. So we're differentiating this function. We already have our f of x here. So now we're differentiating this function with respect to y. And when we are differentiating with respect to y, what are the variables that we're keeping constants? The variables that are not here. So what are we missing? What variables are we missing? X and z. So those are the variables that we are keeping as constants. Okay, so now differentiating this function with respect to y. So the y comes down, so 3 comes down, so 3 times 2, so that's 6, and this is a constant, stays in there, and subtract 1 from it, so 2. Okay, so I hope you got it. Now let's differentiate. So the next step in here is to differentiate this function with respect to z, right? So here we have this, we already have this, we already got this. Now we have this whole function. Now we are differentiating this function with respect to z. So f of x, y, z finally. So differentiating this function that we already have in here and differentiating with respect to z. And what are the variables that we are keeping as constant? X and y. Okay, so the x and y is constant, and we're differentiating only z, and there's no z, only constant, so derivative of constant is 0. Okay, so the derivative of x, y, z, which was our question, so the first one is simply 0, and this is our answer. Okay, next let's move on to f of y z x. So let me write it over here. Okay, so we are finding f of y z x, but first we have to find f of y first. So let's find that. F of y, we are keeping what variables as constant? We are keeping x and z as constant. Okay, so x and z are constant and differentiating only y. So bringing the 3 down and subtracting 1 from it. So bringing 3 down, subtracting 1 from it, becomes 2. And this is a constant, going to stay in there. Okay, oh, I should have used white. Okay, let me change the color. So this is 3x squared y squared negative. Okay, and we're differentiating y. This is a constant. Okay, now once we have f of y, next up is to calculate f of y of z. So let's find f of y of z. Okay, so we are differentiating this function now. We already have f of y here. Differentiating this with respect to z means we are keeping x and y as constant. So keeping x and y as constant, so this whole thing becomes constant. The derivative of constant is 0. And here differentiating z only, so 3 comes down, becomes 6yz squared. Okay, so now we have to differentiate this function with respect to x, right? So f of y of z of x finally. So yz, we already have it over here, right? This function. So we're differentiating this function with respect to x. So we are keeping x and z, y and z as constant, y and z constant. So this whole thing is a constant. Derivative of constant is 0. So this is the answer to f of y of z. Okay. So that's 0 as well. And what was this? It was f of y of z. Okay, now let's move on to the third one, f of z of y of x. And here, as you can see, f of y x, x y z, or x z y, it's the same thing, right? So that's why it's giving, both of them is giving 0, because the order doesn't matter, like I said before. Okay, now x y z. Let's see if this gives 0 as well. It should give 0 because we already know that it's 0 and 0 and the order doesn't matter. So we are expecting this to be 0 as well. So let's see if it's 0 or not. Okay, so first step is to calculate f of z. Okay, now let's find f of z. F of z means x and y are constant, so x and y is constant. Derivative of constant is 0, and this stays there since it's a constant. Bring the 3 down, and z squared. Okay, and now f of z of y. So now we are keeping x and z as constant, and we are differentiating this function now with respect to y. So we're differentiating y only. 3 times 2, that's 6, y z squared, and f of z of y of x. Now f of z of y, we already have it over here. Differentiate this with respect to x, but there is no x, so this whole thing is a constant. The derivative of a constant is 0 as well. So like we said before, so this is going to be 0, and it did turn out to be 0. So as you guys can see, these 3 answers are all 0, proving again that the order doesn't matter and it is indeed equal to 0. Okay, and they're all same. Now our last problem is to find f of x of y of z. Okay, so we are finding f of x of y of z, and for this we first need to find f of x, right? F of x of this function. But you see, f of x we already calculated over here, so we already have it, f of x of y squared. And then we are finding f of x y x, right? So the next step is to find f of x of y. So f of x of y, so this function with respect to y, and we already calculate this as well, so that's 6xy squared. Now I'm moving this to here because I don't have space anymore. Okay, so here I'm going to write what f of x of y of x. Okay, just an arrow that I'm moving in here. Okay, so now f of x of y of x, but f of x of y we already have it over here, so this function differentiated with respect to x. Okay, so the derivative of 6x is simply 6, and y squared since it's a constant. So this is the answer to f of x of y of x. Okay, so I hope you guys liked this video and found this helpful. If there's any question, let me know in the comments, and don't forget to share this with your friends. And thanks for watching. Bye.